Okay, here we're starting to look at interference patterns created by two-slits or diffraction gratings. So first up we have to look at diffraction. Now diffraction is the spreading of waves at an edge or a slit so that waves do not travel in straight lines. Okay, this is more pronounced as slit width approaches the wavelength. So here we got some images of an ocean. So here's the sea, waves are coming in this way, okay, so waves coming in from the sea, and they are straight waves on this side of the break wall. As they go through the gap, okay, they start to curve, okay, so as you see, they start to curve as they go through the gap. The same thing happens here, straight waves on this side, then they hit the wall and then they start to curve, as you can see, like that. So here's a better diagram. So as these waves go through here, they curve at the ends where they were by the wall here, and in this case they're straight in the middle. In other words, the distance here between the distance for the slit, okay, the size of that slit gap is quite large in comparison to the wavelength, and because of that, then the diffraction is not very great. But in this one here, the wavelength is very close to the slit width, so there's quite a lot of diffraction. Okay. Now, interference is an effect that occurs when two or more waves overlap to produce a pattern. What we do is you do superposition to add the things together, but once you do that, you then get the interference pattern. Now, coherence is a term used to indicate that the phase difference between the two waves remains constant and does not vary with time. So if you have a couple of waves, okay, so in this case the blue one, and then we'll do a red one. As you draw them, the phase difference essentially should stay the same. So at each point, the distance from the similar points should always be the same in terms of a measurement. Okay, and the measurement is the phase. Now remember, constructive interference. Okay, what does that do? Well, that creates larger crests and larger and larger troughs. Okay, destructive interference cancels things out. It makes no waves. Monochromatic sources having the same frequency. Okay, so so let's say frequency is the color of the light, so they all have the same color of light. So chromatic is color, so one color light. Now what we're going to do here, we're going to put some waves through two gaps. Okay, so here we have some waves. Actually, I'll do this with a ruler. With a straight line, there we go, much better. Now as these waves go through this gap, they will each diffract, okay, so each of them are going to create a curved path on this side here. Now the wavelength should stay constant, it's quite hard to draw, okay, so that's this one here. And then from this one here, there will also be some curved waves emanating from it. Okay. Now where the waves overlap, you actually get different effects. You get constructive interference there, and you'll get destructive interference here. Okay. So this is constructive here and there, and destructive there, and let's say there. So there's a better picture of it coming up, but this is what happens. So someone here has just tapped both their feet a few times, and they can get some waves going across like that, and they interfere with each other. This is a better picture. You can actually see, because of this bead, there's actually a line along here where there's actually little waves, okay, no waves at all, or just very little ones. And you can see there's quite a few of those lines. So that's what we have there, where there's a line of destructive interference, and we call those nodal lines. The lines beside it, where there are actually waves, we call those antinodal lines. Here's another picture of it. So there's some waves coming in here. They both go through the gaps and they diffract out. Now there's going to be regions where there are no there's no displacement at any time, okay, and those are called nodal lines, okay, or minima, okay. So in other words, where there's regions of destructive interference. There are other lines too, and that's the ones that are going along in between them, where there is maximum displacement by the waves, and we'll call those antinodal lines or maxima.